Hello, my name is Ernest Rutherford, and I am a former student working under Professor J.J. Thompson. My project that I'm working on with him involves atoms and how they are structured. This project entails launching alpha particles at a thin metal sheet and observing how these particles react once they hit the metal sheet. Our objective is to physically prove that Dr. J.J. Thompson's plum pudding model is accurate. Essentially, what this model does is that it provides a structure for what an atom looks like. What it says is that an atom is filled with both protons and electrons, and they are both equally distributed within the atom, but they're all in there together, kind of crammed in like plum pudding, if you're familiar with that. So, since these electrons are equally distributed throughout, we believe that when a alpha particle is shot directly through it, there should be no change in the direction since there is no charge affecting the direction in which it would go. So, that's the goal of our experiment. Should it prove true, that would mean that the plum pudding model is correct. The experiment my colleagues and I performed were done at the physical laboratories in the University of Manchester during July of 1909. Around this time, there were many different scientific advancements happening in the world. Just to name a few, a couple years back prior to when my experiments were conducted, Einstein had published his special theory on relativity. In addition, Dr. Richard Oldham had discovered evidence that Earth has a core. It was also found later that Earth had a boundary between its mantle and crust. So there are many different advances happening during this time. It's a very, very proud moment for science. This project had a small group together who were able to get it done. First off, there was myself, who was the head of the project. I was working alongside my former professor, Dr. J.J. Thompson. However, this was majorly run by me. I also had two of his current students working with me. Ernest Marsden and Hans Geiger were both very instrumental in the performance of this experiment. As I had mentioned previously, I've been serving as the head of the operation conducting this experiment. I was the one who originally created the hypothesis that given the plum pudding model, should you shoot an alpha particle through the atom, it should be able to pass through undisturbed. I have also been serving some of his current students who are Hans Geiger and Ernest Marsden. They have been helping me out tremendously with this experiment and were very crucial to its success. This project was revolutionary in the discovery of atoms and how they are shaped. Not because we were able to prove the plum pudding model, but actually the opposite, because we proved that it was completely wrong. So, as I had mentioned before, whenever you shoot the particle through the atom, it should be able to pass through unchanged. Now, that was the case for the most part, but there were a few instances where when the particle was shot, it would veer off in a different direction, or sometimes bounce directly back. So these changes definitely went against our original hypothesis and proved that the plum pudding model actually cannot be true at all. The findings from this experiment have led to me to create a modification of the plum pudding model, which shows what I believe to be the correct model for the atom. I call it the Rutherford model. So, there's a couple changes on it. First off, we had stated before that in the plum pudding model, the protons and electrons were combined and mushed together, kind of like plum pudding. That is not the case at all. Instead, the atom is completely hollow. This means that should the particle be shot through, it would make sense for it to go through since there's nothing there to block it. Now, for the instances where it did get moved or deflected, this means that there has to be something in there, obviously. So, I believe that there is a positive charge or positive charges on the inside, like very center of the atom, almost like a core. And this core, per se, is what is causing those deflections. So if this were it in this entire area here with the atom, you're shooting the particles through here. They're obviously not being touched by anything. They're not moving, but when it gets close to the core, veers off course potentially, or even just goes directly backwards. These two changes are the key foundations for the Rutherford model, which I believe to be the correct model for the atom.